All right, sophomores, today you get to do a video lesson. Lucky you. Sorry, I'm out with jury duty. So you're going to start the day with a quiz, like always, quiz 7.3. What I want you to do is turn in your textbooks to page 483, looking at number 4. As soon as you do that on your half sheet, turn it in, please. Make sure that you label it quiz 7.3 with your name on it. Show me all your work. And then come back to the movie. Today we're looking at 7.4, parallel lines and proportional parts. By the end of this lesson, you should be able to use proportional parts and parallel lines and triangles. So there's a couple of rules that we're going to be looking at with parallel lines. The first one, the triangle proportionality theorem. This thing states that if we have a line that is parallel to one side of a triangle, in this case that line would be BE, if you can see that, and it intersects the other two sides, then it divides the sides into segments of proportional lengths. All this is saying is that if we have something that's parallel here, okay, parallel to one of the sides of the triangle, it's going to cut that thing, it's going to cut the triangle into the sides of that triangle into proportional parts. So notice, for our example here, we have AB over BC. Okay, so it's going to cut AB over BC. It's cutting that one side of the triangle, okay, is going to be equal to the others. The proportion is going to be the other side of the triangle. So it's going to be AE, that's the longer side, over the shorter side of the other side of the triangle. So AE over ED. So again, if you have a parallel line to one of the sides of the triangle, whatever the other two sides of that parallel line, in this case BE, whatever two sides that thing runs along and hits, it's going to cut those sides into nice proportional lengths. So here's an example of that. Okay, so this is all in your notes, so follow along, make sure you're filling those notes out. This is saying that if PS is equal to 12.5, and I would label it, I don't know why they don't label it for you, but I'll label it here. And then SR is equal to 5. And then it says PT is equal to 15. But we don't know this guy, so I'm going to label it X, TQ. Okay, so we're just going to use our nice theorem, the triangle proportionality theorem. Okay, again, it's cutting the sides that this thing divides, that the parallel line divides. It's just cutting those things into proportions. So let's look here. We have parallel lines, so we can use the theorem. Okay, this parallel line, ST, is cutting line PQ, or sorry, side PQ and side PR. So those are going to be my proportions. So my first thing I'm going to do is I'm going to say, okay, well, PT over TQ is going to have to equal PS over SR. Now it's just filling in what those things are. Okay, so this is what the rule allows me to do. Now it's just filling it in. So we have PT is equal to 15. TQ, we don't know. We're trying to find that, so we'll call it X, equals PS, which is 12.5, over SR, which is 5. Okay, now we have this nice cross multiplication. Okay, so we get 12.5x equals 15 times 5. Solve it for x, and you have your answer. As with most theorems, there's going to be a converse. So the converse of the triangle proportionality theorem just states that if a line intersects two sides of a triangle and separates the sides into proportional corresponding segments, then the line is going to be parallel to the third side of the triangle. So basically, they're going to have to give you something. They're going to have to give you information about these sides here that I'm highlighting for you. They're going to have to give you enough information to determine whether or not those things are indeed proportional. If they are proportional, then we know that ED will be parallel to AC. So basically this is just a test to see if we truly have a parallel line that is within the triangle. All right, so that's why you'll notice here AE over EB So we're just looking at each of the sides to see if they're truly proportional. So AE over EB would have to equal CD over DB. Now, in this explanation here of this converse, they don't give us any of the lengths, but they're going to have to tell us something about that when we go to actually test this in our homework. So let's do an example. Here's an example. Example 2, DG is half the length of GF. Okay, so we know that DG is going to be half the length of GF. And yeah, if you look at it, it doesn't look like it is, but we have to go with what was given. All right, I know that that doesn't look nearly half of DF, but just go with it. EH is going to be 6, and HF is going to be 10. It's asking, is DE parallel to GH? Well, in order to know if they're parallel, if they were truly parallel, then DG over GF would have to equal EH over HF. All right? It's saying here, in this case, that EH over HF is going to be 6 over 10. We know for a fact that DG has to be half of GF. Okay? So, is 6 half of 10? This is actually a pretty easy one because they told us it has to be half, so we know what proportion we're looking for. We're looking for a half. Well, is 6/10 the same as 1/2? Is 6 ever going to be half of 10? The answer to that is no. So our answer is no, and it's because EH is not half of HF. And that's it. For the mid-segment of a triangle, okay, first of all, you need to know what a mid-segment of a triangle is. Mid-segment is a segment with endpoints that are the midpoints of two sides of the triangle, meaning it's going to cut the sides of that triangle exactly in half. All right, that's why we see all these cutting these sides exactly in half. They will always form a triangle inside of the triangle. Okay, the mid-segments of triangle ABC, well, here's the segments. They go from midpoint to midpoint. So RP is 1, PQ is 1, and RQ is 1. Those are the three mid-segments of the triangle. So we're going to use that definition now to come up with a theorem about that. A mid-segment of a triangle is parallel to one side of the triangle. Now notice in this case, all of these sides are going to be parallel. For instance, PQ is going to be parallel to AC, right? RP is going to be parallel to CB, etc. So they're always going to be parallel. So a mid-segment of a triangle is parallel to one side of the triangle, and its length is 1/2 the length of that side. Okay, so what this is saying is this thing here, this parallel line within the triangle, is always going to be 1/2 the length of the side that it's parallel to, the longer side. Which becomes very handy. This rule becomes very handy. Let's look at this. Example 3. Okay, so they want to know the length of DE. All right, well, first of all, we kind of have to make some assumptions here. Is DE parallel to AC? Okay, once we know that DE is parallel to AC, and in example 3 it is given to us that it indeed is. Okay, if we know that, then we know that DE must be exactly half of the side that it's parallel to, because DE is the shorter of the two sides. So all we do here is we take the longer side, 15, divide by 2, that's taking its half, and we get 7.5. Okay, the next thing they want to know is side DB. So for DB, I'll do this in a different color here. We're looking for this red section right here, DB. Well, we know something about the parallel line to this. The parallel line to this full thing, and I'm just going to extend this out by a dotted line here. The parallel to that is going to be this guy, FE, which is 9.2. Okay, well if FE is parallel to AB, we know that FE has to be half of AB, right? So 9.2 equals half of AB. Well, lucky for us, we are looking actually for only half that distance. We're only looking for half the distance from A to B. So this length right here, DB has to be the same as FE. Okay, so DB equals 9.2. Finally, we're looking for the angle FED. Okay, so we're looking for this angle, and I'm going to erase this just a little bit to give us a clear look at this. Okay, we're looking for angle FED. Okay, so how would I find angle FED? Well, I know that FE is parallel to AB. Okay. So what do we know about parallel lines? Their alternate interior angles have to be the same. Okay, so if I have parallel lines here and it's cut by the transversal DE, then FED is going to be the alternate exterior angle. Therefore, it is the same, 82 degrees. Proportional parts of parallel lines. If three or more parallel lines intersect two transversals, then they cut off the transversals proportionally. Okay, so we have three parallel lines here cutting two transversals. They have to cut them proportionally. So when these things go to be cut, these transversals here are cut by these three parallel lines. AB over BC, so this side right here and this side right here, that side over this side has to be equal to EF over FG. Okay, they have to be the same because these are parallel lines cutting the same transversals, so they have to be proportional. So that's all this is saying. Where does this come in handy? This is not in your notes or anything, but I thought this was interesting. So here's an art project. Okay, so art project where we're talking about perspective here. In this picture, AD, let me get a pen that works here, AD and BC, WZ, and XY. All these are supposedly should be parallel lines intersecting the same two transversals, which are these kind of imaginary lines that we would draw in as artists that we would erase. Okay, so they're intersecting those transversals. If we wanted to check to see if we truly did this correctly and we truly made parallel lines here, what we could do is we could just take the distance here on the transversal AB, put it over WX, and make sure that it equals DC over ZY. So it's just one case in which this math can come across in like the art world. But don't spend too much time thinking about that. Let's keep going into what we got to get done for today. And the next section is on congruent parts of parallel lines. So congruent parts of parallel lines. If three or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So if AE, BF, and CG are parallel, and AB is congruent to BC, if they're the exact same, then that means that EF has to be congruent to FG. That's all it's saying. Okay, if these parallel lines cut the transversals so that they're exactly in half on one side, it has to be the same on the other side. So for example 5, here we go. We're going to use this rule right here that we just talked about. Okay, so we have parallel lines, 3 sets of parallel lines. Important to establish that they're parallel. That's what these little things do for us. They are parallel. They're cutting this transversal exactly in half. So since we know that it's also cutting this transversal exactly in half. So that makes it easy for us to solve. We just set up the algebra now. 7x minus 2 has to equal 4x plus 3. Okay, I'll let you finish up the algebra on that. And I believe this is the last example yet before I send you guys free to do your homework. Sorry, this feels a little bit rushed, but here we go. Example 5b. We are to find x, okay? The hint here that I gave you, and something to think about on all your homework problems, is looking for parallel lines. That's what this whole thing's about, is parallel lines, okay? Are there parallel lines cutting 2 transversals? Is that happening here? Well, it doesn't tell us anything about parallel lines, but this tells me that we have a 90-degree angle. This tells me we have a 90-degree angle, which means that these lines here have to be parallel. They have the same exact angle that they're hitting that transversal on, therefore they're parallel. So now we have a set of parallel lines cutting 2 transversals. What do we know about parallel lines that cut through transversals, especially when we have parallel lines cutting transversals exactly in half? Sounds an awful lot like this right here, congruent parts of parallel lines. If we have parallel lines cutting transversals exactly in half, then we know that the other side must be getting cut exactly in half. So what that means is this side right here must equal this side right here, because we cut it exactly in half. Those parallel lines cut it exactly in half. So that makes this easy again. Setting up algebra, solve for x, and you're done. Okay, I apologize that I'm not there to answer more questions for you guys on these. Your homework today is 7.4, number 1 through 25, odds. I will be available by text. As soon as I get out of the courtroom, I'll answer some text messages. Just shoot me any kind of pictures of problems that are giving you issues, and I will try to work them for you, send you pictures back. Or if it's just a real quick question, I can answer it by text or by calling. So give me a call, shoot me a text. Don't be shy if you need help. All right, thanks.